In this video, we're going to examine the remainder theorem of polynomials. The remainder theorem states that if a polynomial f of x is divided by the binomial x minus a, the remainder is the constant f of a. What this means is if you take and do synthetic division as we've done before, whatever occurs, so if I'm going to do synthetic division, let's say we'll do a, and I'll divide whatever polynomial I have, and here's my remainder box. Whatever the remainder is, whatever this value in the box is, that value is as if you plugged a into the function and performed odd order of operations. Your remainder is the value as if you plugged a into the function and performed order of operations. So what does this mean? If I have the polynomial negative 16x squared plus 74x plus 5, and I'm going to do synthetic division with the binomial x minus 3, I'll set up my synthetic division. So I'm going to do synthetic division with 3. I have my coefficients of negative 16, 74, and 5. There's no gap in the exponents, so I don't need to insert a zero term. And then we just do synthetic division. You drop down the first term, you get negative 16. Negative 16 times 3 is negative 48. We add vertically, and we're going to get 26 here. 3 times 26 is 78. And 5 plus 78 is 83. What this means is this remainder of 83 is what you would get if you plugged 3 in for x into the function. If I were to perform the order of operations here, I should get 83 for the value. If we do negative 16 times 3 squared, that's negative 16 times 9, you're going to get negative 144. If you do 74 times 3, you're going to get 222, and then add 5. If you take a negative 144 plus 222, you're going to get 78. And 78 plus 5 is 83. And this is what the remainder theorem states, is if you perform synthetic division, what your remainder is the same value as if you plugged in and did order of operations. So your remainder equals f of a. So I can find my value of a function just by doing synthetic division. So now the question we have to ask ourselves is the factor x minus 3, is that a true factor of the polynomial? Is the binomial x minus 3 a factor? Well, if you have a remainder that's not 0, that means the binomial does not go in there perfectly. And so this is not a factor. And the reason why is because in order to be a factor, the remainder should equal 0. And since 83, does not equal 0, I can say this is not a factor. That is what the remainder theorem states, is if you want to evaluate a function for a specific value, do synthetic division with that value. So if this example was I wanted to evaluate the function at x equals 3, f of 3, I can just do synthetic division, and whatever my remainder is that value. If the value is not 0, then we can determine that binomial is not a factor. If it is 0, then we can state that it is a factor. So let's try a couple more walkthroughs. So when you're doing synthetic division, remember to check your exponents, make sure they're in descending order, make sure there's no gaps. So if I have the expression x to the fourth minus x cubed plus 2x minus 14, and I'm going to divide by x minus 2, in this problem I'm asked to find the other factors. So we're going to do synthetic division here. And so I take the value of 2 and set up my synthetic division. I see x to the fourth, x cubed. I'm missing an x squared, so we use a 0 coefficient. So my coefficients are 1, -1, 0, 2, and -14. And then set up my remainder back. And so I have my remainder box. If this is a factor, my remainder should be 0. And so I go ahead and do my synthetic division. We drop down the first term. 2 times 1 is 2. Add vertically, -1 and 2 is 1. 2 times 1 is 2. 0 and 2 is 2. 2 times 2 is 4. 2 and 4 is 6. And then 2 times 6 is 12. Add vertically, and we get -2. So here's what this means. If we think of this as our remainder theorem, the remainder theorem tells us whatever our remainder is the value as if we plugged it into the function. So f of 2 is -2. Our factor theorem states that if the remainder equals 0, it is a factor. If it does not equal 0, then it is not a factor. And since our remainder does not equal 0, then we could say that x minus 2 is not a factor. So here we examine both the remainder theorem and the factor theorem. And let's do one more example with this. So state if the binomial is a factor of the polynomial. So the factor theorem states, this is a different example. We're going to use this division down below. If the binomial is a factor, then if we were to plug in 3 to this expression, we should get 0. And that's what our factor theorem states. So we're going to look and see, do we get a remainder of 0 doing the division here? So if I take a look, x cubed, x squared, x, I have all my exponents. So I can set up my synthetic division. We have 1, 5, -12, and -36 as our coefficients. We drop down the first term. 3 times 1 is 3. Add vertically, 5 and 3 is 8. 3 times 8 is 24. -12 and 24 is +12. Here's my remainder box. 12 and 3 is 36. And my remainder is 0. That tells me, since I have a remainder of 0, that x minus 3 is a factor. And so if the binomial is a factor, find the other factors. Here's where it gets a little bit trickier. To find the other factors, look at what polynomial remains. Look at your coefficients. Write out what the polynomial is. So we have 1, which is the coefficient for x squared, plus 8x plus 12. Now I know that x minus 3 is a factor based off of the synthetic division and get a remainder of 0. I need to find what other factors are hidden inside of here. And to do that, I'm going to factor. 12 is your product. You have a trinomial. 12 is your product. 8 is your sum. So what numbers multiply to give you 12 and add to give you 8? And that would be 6 and 2. And so this is factorable. So the remaining factors are x plus 6 and x plus 2. Now we're asked on here to verify this with our graphing calculator. To do this, you would just graph your original polynomial, and what would happen is you would have zeros at the solutions to each of these factors, at -6, at -2, and at +3. If you have zeros there, if you have x-intercepts there, and we learned in previous lessons in chapter 6 on how to find those zeros with our calculator, then we can see those are our factors. So to find all the factors of a polynomial, to sum it up, you perform synthetic division with a binomial. If the remainder is 0, as we saw here, then that means your binomial is a factor. So you already have one of them. You take the coefficients that remain, set up the polynomial, here it's a quadratic. And to find the rest of the factors of a quadratic, we can factor out the binomials, and you get the rest of the factors of the polynomial. There are some examples to try on your own, so you can move on to the next video.